Saturn. It is, of course, the ring planet, and the sixth from the Sun. Welcome to the Planets of the Solar System series, where we will learn everything that there is to know about Saturn. Let's start with the physical characteristics of Saturn. Saturn's most distinctive feature is its iconic rings. These are so large that they can be seen through small telescopes. Though these rings look solid, they are actually made of many smaller objects less than 1 kilometer in diameter. These chunks are mostly ice, which allows a large amount of light to be reflected off them, causing the rings to appear extremely bright. Saturn also has a banding pattern in its upper atmosphere, much like Jupiter. However, these bands are less apparent. It is mostly made of yellow and brown colours that are comprised mostly of hydrogen, with a small amount of helium similar to the Sun's composition. These gases appear as jet streams, reaching speeds of 500 km per hour, causing Saturn to be one of the windiest planets in the solar system. If we focus on Saturn's north pole, you may notice a strange pattern. Here you can see that the gases appear to form a hexagon at the top of the planet. But why does it create this shape? Scientists aren't exactly sure. One hypothesis suggests that the hexagon is formed when jet streams around the pole merge with other air currents towards the top of the planet to form a hexagonal shape. Shown in models, the precise speeds that the winds travel at is able to form a hexagon, while other wind speeds have been shown to create octagons and even triangles. So because of these precise wind speeds, this characteristic is unique to Saturn. Though Saturn is 9 times wider than Earth, at 116,000 kilometers in diameter, its surface gravity is comparable to the Earth's, at 10.44 meters per second squared. This is because of its density. Saturn is the only planet in the solar system that's lighter than water, with a density of 0.69 grams per centimeter cubed. If you were able to get a bathtub big enough to hold Saturn within it, it would float on top of the water. Saturn's rings extend the overall planet's diameter to 282,000 kilometers wide, but are less than 1 kilometer thick. Therefore, if you had a scaled model of Saturn that was only 1 meter wide, the ring thickness would be 1/10 the width of a human hair. Saturn also has a very similar interior composition to the other gas giants. Saturn's outer atmosphere is mostly hydrogen with some helium, as explained before, but as we go deeper into Saturn's interior, the hydrogen and helium enter a liquid state. Because helium is denser than hydrogen, it sinks to the bottom and creates 2 distinct layers of liquid hydrogen and helium. We then reach a metallic hydrogen layer, similar to all the other gas giants. This finally surrounds a rocky core, which completes the internal composition. Just like Jupiter, Saturn has a magnetic field, generated by the convection currents in the metallic hydrogen layer. However, this magnetic field is several times weaker than Jupiter, and only slightly weaker than Earth's. Now let's take a look at Saturn's orbit and rotation. Saturn takes almost 29 years to orbit the Sun, and rotates on its axis every 10.7 hours. Its average orbital radius is 1.43 billion kilometers, with an orbital speed of 9.68 kilometers per second. At perihelion, or its closest distance to the Sun, the planet is 1.35 billion kilometers away, while at aphelion, or its furthest distance from the Sun, the planet is 1.5 billion kilometers away. The days on Saturn are quite short, like on Jupiter, at only 10.7 hours for one rotation. Because of its quick day but extremely long year, the Saturnian calendar would have 24,000 days per year. Saturn's axis is 26 degrees away from the poles, meaning that the planet has significantly long seasons. These seasons would last for 7 Earth years, each of which would lead to radically different colours at the poles as the temperature is increased or decreased. Let's look at the moons of Saturn. Saturn has the most moons in the solar system, with 82 overall, 59 which have been confirmed, and another 23 awaiting confirmation. The biggest moon of Saturn is Titan, which is the second largest moon in the solar system at 5,150 kilometers wide. Titan is a very unique moon. It has an extremely thick atmosphere for a moon, approximately 50% denser than Earth's, and is mostly made of nitrogen and methane. This is the only moon in the solar system to have substantial atmosphere and weather. Titan has a unique characteristic where the temperature of the moon around minus 180 degrees Celsius, enables methane to exist as a liquid on the surface. This means that on the moon, instead of water, it rains methane and has lakes of liquid methane across its surface. Some of these lakes are hundreds of kilometers wide and hundreds of meters deep. Its surface is mostly water ice, which could hide an underground ocean beneath. Another feature of Titan is that it is tidally locked to Saturn. This means that the same side faces Saturn all the time. Titan orbits Saturn with a mean distance of 1.2 million kilometers and completes one orbit every 16 days. This means that a day on Titan is 16 Earth days. Another interesting moon of Saturn is Enceladus, which is a potential host for life. This small ice ball of a moon, which is a tenth the size of Titan, definitely has a subsurface ocean. Water geysers have been seen by Cassini erupting from the surface and shooting alien water hundreds of kilometers into the air. Some of this water was analysed by the Cassini Probe and was found to have the building blocks of life. Enceladus will definitely be one of the top candidates for life in the future. Other large moons of Saturn include Mimas, Tethys, Dione, Iapetus, and Rhea. Let's finally look at some interesting features of Saturn. The one thing that everyone talks about around Saturn is its rings, but a closer look shows us there are actually many smaller rings that make up the whole structure. On first look, there are three main rings of Saturn, A, B, and C rings. But when zooming in on these rings, you can see that there is even more individuals. Cassini Probe counted as many as 30 distinct rings when orbiting around Saturn. Saturn's amazing rings were either formed from a moon or leftover debris from the early solar system's formation. The first theory for the rings' formation was that a moon of Saturn called Veritas, whose orbit decayed until it broke up from tidal forces, produced the rings. This happened some 100 million years ago, and is the more likely of the two theories, as seen through evidence from Cassini. The second theory is that it formed around 4 billion years ago with the formation of Saturn. The rings during this early time in the solar system would have been much thicker than they are now, approximately 100 kilometers across, and mostly made of icy material. However, as the solar system aged, the objects within the ring system collide, and the larger objects are slowly filtered out, leaving a thinner layer of objects behind. The final result of these theories is a highly reflective but thin ring system that will probably only last another 300 million years. Now, throughout this video, we have been talking about the Cassini Probe, which orbited Saturn from 2004 to 2017. This probe was revolutionary in our understanding of Saturn, its moons, and its rings. Cassini gave us the most detailed images we had ever seen of Saturn and its moons. It discovered organic molecules on Enceladus, 6 new moons, over 30 individual rings of Saturn, and analysed the Saturnian atmosphere when it finally crashed into the planet at the end of its mission. Without Cassini, we would never have found out so much about the planet, as the last spacecraft to visit it was the Voyager probes. Not just that, but Cassini also held another spacecraft, known as the Huygens, which was dropped onto the surface of Titan. It was able to send back data and take pictures of the moon for 90 minutes until it lost communication. This is the furthest landing any spacecraft has managed, and was revolutionary in learning more about Titan. The Cassini-Huygens mission was one of the most successful missions ever, and will leave a legacy for future endeavours to the planet. And finally, I will leave you with this. This is an image of Saturn taken by the Hubble Space Telescope in 2019, during its summer for the Northern Hemisphere. It truly is one of the most beautiful planets in the solar system. And if you've made it this far, I want to thank you for watching this video, and remember to leave a like if you enjoyed. There are only 2 planets left, so subscribe to not miss the next one, and until next time, goodbye.